Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Erina Nisha binti Azmi. So today we are from Group 9. We'll be present our group project titled Applying a Forecasting Model for the E-commerce Development of KSP Airport during COVID-19. Now I will explain about the pattern of the data. The data was collected from the air cargo that handled by PIA. So we want to analyze the component of the data. There are four main type of component, which is irregular, cyclical, trend, and also seasonal. Therefore, the data from the air cargo, we try to plot it into the line plot in the Microsoft Excel. So on the graph, we see that Y is represent of total of air cargo, and also X is represent the year. Based on the graph, we can see that there is a declining downward of the data from the year 2008 until year 2020. So it shows that there is not a cyclical or irregular component. It also has not a trend component since it has no general upward or downward movement within the value. But we can see that there is a seasonal component within the data since it shows a regulatory fluctuation within the period with a regulatory pattern. After we identify the component, we use a forecasting model to analyze the data. So we use a decomposition method. Decomposition method is easy to understand since it is the analysis of individual component of the time series. So we divide the decomposition method into the two types, which is first multiplicative decomposition method and second is additive decomposition method. The first method is multiplicative decomposition method. The method was a product of the four components, which is seasonal, trend, cyclical, and also irregular. So to calculate it first, we must find the seasonal index using the center moving average. After that, we find the unadjusted seasonal and we remove the irregular component. And then by using the deseasonalized time series, we try to identify the trend component and calculate it using the regression analysis. And then the last step is we find the predicted value. After we get the value, we try to calculate the error using the MSE, RMSE, and also MAPE. To calculate the error, we try to divide the calculation into the two partition, which is modeling and also evaluation. The modeling we try to take from year 2008 until 2018, while for evaluation we take from year 2019 to 2020. So in general, we get that MSE value is 16226 175.4.05, and then for RMSE is 4028.17 and MAPE is 9.55. The second model is additive decomposition method. Additive decomposition method is a sum of the four components, which is seasonal, trend, cyclical, and also irregular. The step to calculate is almost same with the multiplicative decomposition method. The difference is when we want to calculate the unadjusted seasonal, we use the formula YT minus with center moving average. But when we calculate unadjusted seasonal for multiplicative, we use the formula YT divided by CMA. And then after we calculate it, we'll try to find the error by using the MSE, RMSE, and also MAPE. After that, we get the value of MSE is 16177,822.91. For RMSE, we get 4022.17, and for MAPE is 9.55. Therefore, if you want to compare the two models, the additive decomposition method is better since it has a less error than multiplicative decomposition method. But we need to compare with the 5 model to get the best fit model.
Okay, now we use Holtz-Winter method. There is two types of Holtz-Winter method, which is Holtz-Winter multiplicative method and Holtz-Winter additive method. Okay, now I will explain about Holtz-Winter multiplicative method. Okay, Holtz-Winter multiplicative method, it is calculates exponentially smoothed values for level, trend, and seasonal adjustment to the forecast. Okay, the first step is we need to calculate the initial value of AT, ST, and TT. Okay, then to get a forecasted value, we use formula which is t plus m equal to at plus tt multiplied by m, and all of that is multiplied by st minus l plus m. Okay, then we divide to the three part, which is a modeling part, evaluation part, and general part to get the value of MSE, RMSE, and MAPE. Okay, for the value of modeling part, for the modeling, there is a 40 data that we use. The value of MSE is 248792183.68, and you can see that the value of MAPE is 34.64. Okay, then for the evaluation part, the value of MAPE is 12.20, and the value for general part is the value of MAPE is 30.90. Okay, then for the Holtz-Winter additive method, it is an extension of Holtz exponential smoothing that captures seasonality, and we use formula to get the forecasted value, which is ft equal to at plus t tm plus st minus l plus m. Okay, the differences between multiplicative and additive is for multiplicative we multiple the st, and for the additive we plus the st. Okay, and the value of MSE, RMSE, and MAPE is okay, there is a three part, modeling, evaluation, and general part. And for value MAPE of modeling part is 6.85, value of MAPE for evaluation part is 6.27, and value of MAPE for general part is 6.75.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi bin Muhammad Khalil. My metric number is 264911. So I will present about box janking ARIMA. So the first step in box janking is to determine the existence of a seasonal component and determine whether it is stationary. If not stationary, the data would be transformed into a stationary time series by taking a suitable difference. The legend box test was used to measure the white noise and residual in the study with autocorrelation function ACF and partial autocorrelation function PSCF. From the figure below, the result shows that there is a decay exponentially in SCF and PSCF has a spike. The SCF fluctuated below and above of the value 0. There is one bar that spike on PSCF, which is at a lag 1, so we can use an auto-regressive AR model function. Because of that, it's safe to tell that the process can be best used in an ARIMA model to be tested. Next for model fit. So based on the table 2, we get a value of root mean square error RMSE and mean absolute percentage error MAPE. To find a value mean square error MSE, we calculate the value of RMSE square. So we look the value of RMSE is 3170.807, so we square that value and we get the value of MSE is 10054,017.03. In the table 3, it shows that R square is more than 50%. The R square is the value of R square is 0.545, and the legend box is significant value is 0.876. Therefore, the error is a white noise. Other than that, the parameter model is significant since the p-value is less than alpha, which is 0.05. Okay, next for best fitting model. So we do comparison between the 5 model, which is the decomposition method, which is multiplicative decomposition method, and additive decomposition method. Exponential smoothing include Holtz-Winter multiplicative method and Holtz-Winter additive method, and box janking ARIMA to find the best model. The best fit can be evaluated by using the error value of mean square error MSE, root mean square error RMSE, and also mean absolute percentage error MAPE. So for the 5 model that has the less error is is the best model that can be used for forecast. So in the table 5, shows that Box Jenkin Arima has a lower value error for MSE, which is 1005401.03, RMSE 3170.18, and MAPE 6.51. Therefore, we choose Box Jenkin Arima method as a model, the best model to be forecast. The model will be used to forecast to short term and long term. So, since we already get a best model through MSE, RMSE, and MAPE error, it was determining that model that will be used in Box Jenkin Arima method. Thank you.
For short-term forecast, we do for 2 years ahead, which is for 2021 and 2022 for the 4 quarters. To forecast the value, we use an IBM SPSS software to forecast the 2 years ahead. The forecast value is increased for 2021 and 2022 from quarter 1 until quarter 4, except for quarter 1 year 2021. The forecast value quite low. Next, for the long-term forecast, we do for 6 years ahead, which is from 2021 until 2026 for the 4 quarters. To forecast the value, we also use an IBM SPSS software to forecast the 5 years ahead. Okay, as can be seen in the table, it shows that quarter 1 has a lower value compared to other quarters started from year 2021 until 2026. But there is growth for every year for the company. Therefore, the air cargo company will keep on increase during the 6 years ahead. Due to COVID-19 crisis, the trend of e-commerce using air cargo in Malaysia is increasing. Time series analysis has been used as a tool to find the best model in forecasting the KXP's strategy and development. Time series forecasting is the process of studying the time series data using statistics and modeling to make produced forecasts and guide the strategic decision making. Time series analysis is creating models to get an idea of the data in order to determine the possible factors. For this paper, the time series analysis have been applied for 5 different time series models, which are additive decomposition method, multiplicative decomposition method, Holtz-Winter additive method, Holtz-Winter multiplicative method, and Box-Jenkins Arima. To find the best model, the model's performance will be evaluated using the error measurement. There are 3 error measurements, which are MSE, RMSE, and MAPE. Okay, so the best model that has been chosen was Box Jenkins Arima. Then we conducted a short-term forecast for 2021 to 2022 and long-term forecast from 2021 until 2026. So from the forecast, it shows that the e-commerce of air cargo of KXP for the next 6 years will be increasing for every year. The experimental and assumptions established for the model development do have constraint in terms of validity, and this issue cannot be avoided. The other models that not include could be the best models to forecast the KXP's air cargo. Therefore, professionals could use other models to conduct further study in this area. That's all from our group. Thank you.